Hey everybody, so after class today, I worked with um, Ben and Kirtika and Angelina, and I came up with a practice class definition problem, one that would be similar to what's going to be on Thursday's exam. So I wanted to go over it, not only or not just post the files, but also go over it in a little video here. So, um, like what will be on Thursday's quiz, the class is kind of an algebra-based class. And this class is a linear equation class, and it says write a class named linear equation representing any linear function excluding perpendicular lines which have no slope. So that means you do not have to worry about handling the situation where b is equal to 0. And I'm not talking about b being the slope intercept. I'm talking about b from ax plus by equals c. Okay, so the class has three double instance variables, a, b, and c, representing the equation ax plus by equals c for the function, where b is not equal to 0. The class has two constructors, one constructor with no arguments, assigning 1.0 to a, b, and c, and one constructor with parameters for a, b, and c. The class has getter and setter methods for a, b, and c. The class has a public method named getSlope with no parameters. It returns a double value equal to the slope of the line, which is computed using the formula negative a over b. And this is why you can assume that b is something that will never be 0, because of course if you try to do negative a divided by b and b is 0, you're going to get a runtime error. So that's why it says you can assume that we don't have a vertical line with no slope. The class has a public method named rPerpendicular. It has a public method named getYintercept with no parameters. It returns a double value equal to the y-intercept, which is computed using the formula c over b. And the class has a public method named rPerpendicular. It has one linear equation parameter named other. It returns true if this linear equation object is perpendicular to other. Otherwise, false is returned, and two lines with slopes m1 and m2 are perpendicular if and only if m1 equals negative 1 divided by m2. Okay, the class has a public method toString with no parameters. This method returns a string representing the linear equation object in standard form. That is ax plus by equals c. For example, if the linear equation object has the values 5.3, negative 1.0, and 23.1 for a, b, and c, the method should return 5.3x minus 1.0y equals 23.1. So if a is 0, the method should return the equation by equals c. So if a is 0, that's the coefficient of x, so it wouldn't really, ax wouldn't be a term then. So it should just do by equals c. Okay, so when you want to be systematic, and when you attack these programs or these writing these classes, and look at the details and make sure that you don't skip over one of the methods inadvertently that you need to write. So I'm going to start at the top, and I'll show you what my solution is. Write a class named linear equation. Okay, public class linear equation. Okay, that's the class header. It should be public. Notice there are no parentheses, and then you have an open curly brace. Okay, the class has three double instance variables, a, b, and c. Let me fix a typo here. Representing the equation ax plus by equals c. Okay, so I'm going to make three instance variables. Instance variables are always private, and these are all double variables, so I can declare them in a single statement. It would be fine if I said private double a, comma, or semicolon, and on the next line private double b, semicolon, next line private double c. semicolon. But since they're all the same type, I can declare them all at once. Okay, then it says two constructors. One with no arguments, assigning 1.0 to A, B, and C, and the other with parameters for A, B, and C. So this first one is the one with no arguments, and also you'll notice there are no parameters, so no arguments can be used when you make an object using this constructor. So public constructors must be public. Then there's no return type and there's no void. You just have linear equation, the name of the class. And then the no args one will just have parentheses. And then in the curly braces, you assign, it says assign 1.0 to A, B, and C, right, which assigns 1.0 to A, B, and C. So I'm going to have A equals 1.0, B equals 1.0, and C equals 1.0. Okay, and then I have a constructor, another constructor that has parameters for A, B, and C. So the parameters, the data type has to match the data type of the corresponding instance variables that they'll be assigning a value to. So in this case, I have three double variable instance variables. So that means I need three double parameters. And I'm going to call one A val, another one B val, and another one C val. And then I'm going to make assignments to A, B, and C with those values, or with those parameters in the body of the constructor. Okay, and then we have getter and setter methods for each of the variables. So I did them already for A. Okay, so it's public double get A. Getter methods always return a value, and the data type of what they return has to match the variable whose value they're returning. So this one is get A. So we're going to return A, and A is a double, so that's why the double is specified as the return type. Okay, then the setter method is right there. It is always a public, and so must the getter method be always public. And always void. It's always a void method with a parameter. Because the goal of the setter method is to assign a new value to the instance variable A, to whatever instance variable it's set up for. So, so since A is a double variable, that would mean that we need a parameter that's a double value, and we would assign that value to the instance variable. So in a way, setter methods look a little bit like constructors, except instead of assigning values for all of the instance variables or having parameters for all of the instance variables, they only assign a value to one of the variables. And of course, the other key difference is constructors do not have the word void or a return type, and they are just the name of the class. Okay, so these are my setter methods for B, and I think I still need to do C. So let me copy and paste and replace B with C. And that would be C and C. There we go. Okay, so so that's the class header, the instance variables, the constructors, and the getter and setter methods. And there are a few additional methods to write here. It says the class has a public method named getSlope with no parameters. It returns a double value equal to the slope of the line, which is computed using the formula negative a over b. Okay, so even if you don't know what source code goes in the method, you can at least set it up. And in this case, I think you will know, but you would at least know to make a public method that returns a double value and what its name is. And it says it has no parameters. Okay, and the slope value, it turns out, is -1 times a over b. So all you need to do is say return -1 asterisk a divided by b. Okay, and then we have the get y-intercept, and that just returns c over b. It also gives you the details about it. It's a public method with no parameters. It returns a double value. Its name is get y-intercept. Let me make sure I actually called it. Yes, I did. Okay, and then there is r perpendicular to each other, or the method r perpendicular. It has one linear equation parameter named other. Returns true if this linear equation object is perpendicular to other. Otherwise, false is returned. So that tells you that it's going to be a return type is going to be a Boolean value. The name of it is r perpendicular, and it has one linear equation parameter named other. And I think I called it other LE here. I'll just call it other. Oops. Okay, so my equation then, or my source code for r perpendicular is if get slope, so I'm calling the get slope method of this class for this object, is equal to, so equals -1 divided by other dot get slope. So I'm calling the get slope method for the other linear equation object that is the parameter. So really we're comparing the slope of this object to the slope of the other object, and checking to see if there's a relationship -1 divided by other dot get slope. If that's the case, I return true. Otherwise, I return false. And then finally, the toString method. If a is 0, return b plus y equals, in quotation marks, plus c. So notice the plus here is for string concatenation. We're concatenating a number to a string and then concatenating another number on the end. So that's the case where you would get an equation like 7y equals 4 because there was no x term because a is 0. All right, and then finally, you might think you just then otherwise return a plus x plus b plus y plus c, but it turns out that there's two different cases. If b is less than 0, you're going to return a plus x plus b plus y equals plus c. So the negative sign that is naturally occurring with b when b is less than 0 is going to make itself known, so that we would get something like 4x 4.3x and then minus 3.4. So the minus 3.4 is going to come straight from the b value, whatever b is, and then the y equals is a part of the string, and then whatever number we have. So it turns out in the case where b is positive, you have to make one little tweak. You have to put a plus sign in along with the x in quotation marks, because when you go to concatenate x to it, if you don't add that plus sign and you just say plus b, this is what you get. You get no plus sign in your string. So that's one of the caveats, a small little detail, that you want to pay attention to. Okay, and then it says in the class with the main method, create three linear equation objects, EQ1, EQ2, and EQ3. Create EQ1 using the no-args constructor, EQ2 using the values 1.0, 2.0, and 3.0. for A, B, and C, and EQ3 using negative 2.0, 1.0, and 4.0 for A, B, and C. Then use system.println and the toString method, print out the equation of each object, and then use system.println and the rPerpendicular method, print EQ2 and EQ3 are perpendicular if they are perpendicular, okay, to each other, and EQ2 and EQ3 are not perpendicular otherwise. Okay, so in the class with the main method, I'm creating 3 linear equation objects. The first one is the no-args constructor. The second one uses 1.0, 2.0, and 3.0. And the third one uses negative 2.0, 1.0, and 4.0. Then I call system.println. And interestingly enough, I think as I told you in class, when you put an object reference in the parentheses of system.print or println, the toString method is automatically called. So I could either put eq1.toString or I could just put eq1. Same with eq2 and eq3. Either would work. And then finally it says check or run the call the rPerpendicular method with eq2 and eq3, and then if it returns true, print they are perpendicular, otherwise print they are not perpendicular. So that is what's going on there, and when I run it, this is the output that I got. Okay, so you can see I picked A and B values that would result in perpendicular lines, and it did pass the test. Okay, I'm going to just test a few other parts of my program. I'm going to say linear equation EQ4 equals new linear equation, and this time I'm going to provide a 0 value for A. Okay, so this is actually really the equation of y point y 1y equals 1, or just y equals 1, which is a horizontal line. So then I'm going to say system.out.println EQ4, and I'm going to say system.out.println, and then let's do EQ4.getSlope. Okay, and then I'm going to do system.out.println EQ4.getYintercept. Okay, so the slope of the line y equals 1 is 0 because it's a perfectly horizontal line, and the y-intercept goes right through 1 on the y-axis, so it should say 0.0 and then 1.0, and then when I print it I should get 1.0 y equals 1.0, and let's run it and see what we get. And let's see, I know, when I was showing you the issue with toString, I forgot to delete that. Okay, so let's go back and let's run it. And there we go, 1.0y equals 1.0. Let's see, negative 0.0. I wonder why I'm getting the negative sign. And then y-intercept is 1.0. So let me go look at my get slope. Negative 1 times A divided by, not 100% sure why I'm getting negative 0.0 when I do negative 1 times A. So negative 1 times A should give me 0.0. because A is 0 in this case. Then when I divide by B, which is 1, I should get not negative 0.0. Not sure about that one, but technically it is 0. Okay, so that's it. I'm posting this along with the actual 2 files that have the source code for this. So hopefully this was helpful. And yeah, we'll see you on Thursday.